All right, guys. So I decided to get my COVID-19 test. All right. Not that I'm feeling sick or anything. I just thought it'd be a good idea, to get tested and make sure that I'm, good to go and don't need to take, extra precautions. Okay. So I tested negative. This is awesome. I'm so excited. But wait, does that really mean I don't have COVID-19? We're going to talk about that and more in this video. We're going to talk about how to calculate conditional probabilities, what positive predictive values and negative predictive values, what do they mean, and what's sensitivity and specificity. Okay, so first thing first, I went online and did a little research into the test that I got. Okay, and they gave me all this really cool information. And they told me what the sensitivity and specificity and positive predictive value at some sort of assumed prevalence and a negative predictive value at an assumed prevalence. Okay? Gave me all these estimates. So, great. But what does it mean? Based off of the positive predictive value, negative predictive value, and sensitivity and specificity estimates that the FDA gave us, this table is pretty realistic, although it's not based off of, I didn't find this data in particular online or anything, okay? But it's pretty realistic based off of the estimates that they gave us, okay? So what are we looking at here? We see positive tests, negative tests, and then we also see people that have COVID versus not having COVID. Okay, so great. I have a negative test. Is it true that I'm COVID negative? Well, if we look at the data really quick, I have this negative test. One person has COVID, 940 do not have COVID with the negative test. Very interesting. So I can't say for certain that I don't have COVID, but I can say something about the probability that I have COVID. So, what is the probability that someone is COVID negative given that they have a negative COVID test? Okay, in statistics, we call this the negative predictive value. Okay, so this question is basically asking, what is the negative predictive value? Okay, and we would write that out using statistics language as the probability of being COVID negative. Okay, I'm going to use the little dash sign to mean negative. Given, okay, in statistics we use this bar to represent the word given, that they had a negative COVID test. All right, so how do we figure this out? All right, recall in probability, we always take on the numerator, it's like the number of the events that we're interested in, right, divided by the total, right? In probability in general, that's how we find probabilities, okay? So let's start with total. If it is known that we have had a negative COVID test, then the total number of people with negative COVID test is our total, right? So our number in our total will be the total number that have had the negative test, okay? Negative test, the total number that have had the negative test is 941, okay? So we're really only dealing with the highlighted data. All the rest of the data, it's just extra information at this point, okay? So how many of those with negative test are actually COVID negative? 940. Okay, so what is 940 divided by 941? It's 90.9989, which is basically saying that this has a negative predictive value of 99.89%. Okay, and that's my answer. So I can feel pretty confident that I don't have COVID. So now moving on. What's the probability that someone is COVID positive given that they have a positive COVID test? Okay, so I didn't have a positive COVID test, but let's just say I did. Then what would be the probability that I actually have COVID? Okay, so what this is called is the positive predictive value. And in probability speak, in statistics, the way we would write this is the probability of having COVID, so COVID positive, and then given, right, conditional probability, we always use that bar, that they had a positive test. Okay? So once again, when I do probability, I usually start with a fraction bar, and on the bottom is the total, right? So right now it's given that they have a positive test. So really, I'm only dealing with this data here. The rest of the data is just kind of extra information lying around, right? Because all I care about is people who have positive tests right now. It's given that you have a positive test. So there's 59 people that have positive tests. Okay. So now what's the probability of being COVID positive in that group? Well, 49 have positive COVID out of the 59 that have a positive test. Okay, so that is 0.8305, or in other words, 83.05%. Okay, so if you have a positive COVID test, it's pretty likely you have COVID, right? But not as confident about not having COVID with the negative test. Okay, moving on. So what is the probability that someone has a negative COVID test, given that they are COVID negative? Okay, so it's given that they're COVID negative, and we want to find the probability of having the negative test. This is called specificity. Okay, as a patient, this is really less interesting to you than the negative predictive value. But to a doctor, it's super interesting because, remember, doctors are really interested in knowing how good is that test, versus a patient's really concerned about themselves, and they get the test and they want to know, well, what's their chance of having COVID given that they just have this test. Okay? So the specificity, the way we would write this using probability, we'd say probability of has a negative COVID test, so negative test, given, right? Given is always that bar, they are COVID negative. Okay, so you see that this is the exact, if I reversed these two, then I would be doing negative predictive value. Okay, so specificity is kind of the reverse of the negative predictive value. Okay, so how would I calculate this? Well, so right, it's given that you're COVID negative, so that means you definitely belong to this group here. Okay, so forget all the rest of the data. All you care about is that data right there that I've highlighted. So this is going to equal, in the denominator, you have the total, 950. How many of those have the negative test? The negative test is the 940. All right, this equals 0.9895. All right, in other words, 98.95%. Okay, so if you are COVID negative, it's a pretty good chance that you are going to have that negative test. Okay, so what about finding the probability that someone has a positive test given that they are COVID positive, right? This is called sensitivity. Okay, and the way we would write this problem using probability, it's the probability of being positive COVID test, so positive test, given that you are COVID positive. Okay? All right, so since it's given that you are COVID positive, we are only dealing with this data here, the data I've highlighted. Okay? So on the denominator, we would have those 50 COVID positive people. Okay. Then in the numerator, we would only be concerned about the positive test folks, 49. This equals 0.98, or in other words, 98%. So the sensitivity for this is 98%, which is really good. Okay, one more thing I want to talk about is how do I find the probability of someone being COVID positive and having a positive COVID test? Okay, so notice that this is not using the word given, right? This is not a conditional probability. I'm not asking for a conditional probability right now, okay? What I'm asking for is the probability of being COVID positive, okay, and having a positive test. So how do I figure this out? Well, since I'm not being given any information, really I'm dealing with the whole table. I'm not just highlighting one row or one column. The whole table is my data, okay? So on the denominator, I'm going to have all 1,000 people, okay? So when you don't have a conditional probability, but you're doing something and or something along those lines, then you're going to have that 1,000 down there on the bottom, okay? Okay, so let's now look into our table and see how many of them are COVID positive and have that positive COVID test. So let's see, COVID positive are these folks, positive test are these folks, so that's this guy right here. 49, okay? 0.049, or in other words, 4.9%. Okay, and the reason for this is because the prevalence of having COVID in this population is really small. It's somewhere near 5%. It's very unlikely of having COVID. But if you have COVID, it's very likely that you'll have that positive test.